Last section, 16.3 on the quadratic formula. Take a couple minutes here with me for the background, and this will help you remember how to do the questions. So, want to contrast first between linear and quadratic. So, linear here is something like y equals 3x plus 4. If I graph that, I have it y-intercept of 4 and a slope of 3, some kind of a straight line. So that's what the graph of this type of equation looks like, is a line. If I have a quadratic, what does that look like? You could think about just the y equals x squared part to get the general shape and say, what kind of a table would I have? So if x is 0, then y would be 0, 0 squared. 1 squared is 1, 2 squared is 4, 3 squared is 9. And if I had negatives, I would have the same thing. So what is that looking like? 0, 0, 1, 1, 2, 4, 3, 9. I start going up a lot faster than I'm going over. And so that gives me a curve, a parabolic curve. If I have negative inputs, I would have positive outputs curving up here the same way. So here is the shape of a quadratic. Now, when I get other pieces on it, so if I include all of this, then I might have something that is shifted over, it might be squished, something, but it's still this general shape in order to have the quadratic. What does that mean? What we're going to focus on is finding the x-intercepts of the quadratic. So if I want the x-intercept, I'm solving when y is 0. This is the focus of section 16.3. On the picture, what we're asking is, where does this curve cross the x-axis? When does y equal 0? At what values for x? So you can see in this picture, we have two answers. And that's the most common. But if we shifted that parabola up, we could end up with something up here that never crosses. This would have no solutions. Or if I have something like our very first one, actually, let's just look at that and get a highlighter on that. So this first parabola just touched down once. So this gives us three possible options. We had no solutions. We have two solutions. And we have one solution. By solution, we're talking about this equation. When does the parabola equal 0? So there's a formula. This one do want to memorize, but I want to tie it into the graph to help you remember it. Where does it cross? If you go through a bit of algebra, you can show that it's going to cross at two numbers potentially. So what we need to do is find where the center is here. That's going to be take negative b over 2a. So we have our a, b, and c coefficients. If I take negative b over 2a, that puts me smack dab in the middle of my curve. But then I need to move out to the right and to the left to get to my intercepts. So to do that, we say add something to go right, subtract the same amount to go left because it's symmetrical. And how much is it? This comes, our interesting piece, square root, thus the radicals, of chapter 15, square root of b squared minus 4 times a times c. So, what can happen? If we're trying to take a square root, then we could not get a real answer. That is, we could have square root of a negative number. Square root of negative 16 is not a real number, and that would be the scenario of no solutions. If we would end up with square root of 0, then if I add or subtract this, it doesn't make a difference. That is when we have one solution. And any positive number here, 37, anything, whether it's a perfect square or not, it doesn't matter. Any positive number gives me 2 solutions. So this is just the part of the formula. This one, 0 gives us 1 solution, and a negative number gives us none. So let's take this formula and use it on an example. So you might want to pause a bit and reflect on this and before you go ahead. All right, it has a fancy hat on it. I can take that off. What does this look like when we encounter real quadratic equations? Number 1, negative 2x squared plus 2x plus 7. First is getting my a, b, and c. So I look for, let's write it out here, a equals b equals c equals. So I look for the x squared term, that makes it a quadratic. That gives me my a. So a is negative 2. There's no x's when you get a, b, or c. You use the x's to tell you which number to pull off. So a, b, and c are numbers. Then we look for the x term, and that gives us our b. And then we look for the constant, and that gives us our c. So next step, let's go ahead and calculate this part. The part underneath, underneath the radical is called discriminant because it tells us how many solutions. So let's do the discriminant first. Discriminant, b squared minus 4ac. So this would be 2 squared minus 4 times negative 2 times 7. And so that one, 4 minus 4 times negative 2 times 7 is 60. 60 is a positive number, so we're going to have 2 solutions. What are they going to be? We use our formula. Going back to black, x equals the opposite of b. So if b is positive, like we have here, positive 2, then opposite of b is negative. If b had been a negative number, then opposite of b would be positive. So don't think that up here I have to have a negative number. It's always the opposite of sign for b. So negative 2 plus or minus square root of 60. We already calculated the discriminant under there. Over 2 times a. A was negative 2. So I'm going to simplify the denominator. Negative 2 plus or minus square root of 60 over negative 4. Oh, at the same time, Hawks does want you to simplify the radical, what we were just looking at. So square root of 60. 60 is, so I'm actually going to think about this over up here. 60 equals 2 times 30. 30 is 2 times 15. 15 is 3 times 5. No perfect, so the 4 is a perfect square. So 60 is 4 times 15. That's helpful. And so then I can say negative 2 plus or minus 2 from the square root of 4. And then what's left under the radical is 15, all over negative 4. And you'll enter this as the two solutions, one for the plus, one for the minus. So a little bit of help in keyboarding. X will equal negative 2 plus 2 root 15 over negative 4, comma, negative 2 minus 2 root 15 over negative 4. And that's your two solutions. Those are the coordinates where that parabola crosses the x-axis. Okay, a couple more examples. Number 2, we have this in the correct form already. We have equal to 0. It's very important that you have a 0 on one side in order to use this formula. So now we can get A, B, and C. Look for your x squared term. That gives you your A, negative 25. Look for your x term. That gives you your B. Include the sign on it, whatever that is. This is a positive 20. And your constant, whoops, which is negative 4. Now let's go ahead and get our discriminant. So b squared is 20 squared minus 4 times negative 25 times negative 4. So this gives me 400. Note that if b was negative, b squared is still positive. Sometimes the sign there, people entered in the calculator wrong. So keep your logic on and be sure that your b squared ends up positive. 20 squared minus 4 times negative 25 times negative 4. This all gives me 0. 0, what does that mean? That means when I add 0 and subtract 0, I get the same answer. So I'm going to get one solution. But we still need to figure out what it is. So let's write here, this implies one solution. What is it? X equals the opposite of b, so the opposite of 20 is negative 20, plus or minus square root of discriminant, which was 0, over 2 times a, which is negative 25. So my denominator has negative 50, my numerator has negative 20, the 0 part just disappears, so we get positive 2/5. That is where the parabola touches down. One more. Let's pull it up. So the question came out in this form, but we need 0 equals. Watch out for that because a lot of the questions already have it, so you can forget that you actually need to have it set out that way. So what I did to get over to that form is I say, let's add 3y squared to both sides. So that would give me negative 7 equals 3y squared minus 8y. And then I would add 7 to both sides. So this was plus 3y squared. Add 7 to both sides, and we get 0 equals 3y squared minus 8y plus 7. This is how I got over to here. I'm going to go ahead and erase this now. Let's just keep working from there. All right, so A B, and C. Look for my squared term, take the number on it, positive 3. Look for my y term, take the number on it, negative 8. Look for my constant term, take the number with the sign, positive 7. Now I can get my discriminant. So I have b squared, so this is negative 8 squared. That negative needs to be inside the parentheses if you're going to write it there at all. Minus 4 times 3 times 7 equals 64 minus, and we have 12 times 7 is 84. 84 equals negative 20. We have a number below 0 that we're putting under the square root. So this means no real solutions. There are ways to work with the complex numbers that you would see in pre-calculus. We would stop at no real solutions in this class. Enjoy.